Now, we've looked at Visual Studio. What we're going to do now is show you the differences between Java and C#. And there's not much. It's a slightly longer agenda, but we'll go through it fairly quickly. Things are very short. I'll show you what the source file conventions are, as well as what data types and the differences between the Java ones and the C# ones, the operator differences, flow control, looping statements, class fundamentals, and just overall give you a solid understanding of C# if you're coming from a Java background.
So this is the part where we all brace ourselves.
Because
we're expecting such huge differences, and really, you're actually going to debunk the myth and say, well, yes, there are differences for sure, but they're not as crazy as you might think.
Not as crazy, and believe me, you'll see it as we go through this.
And by the way, just so that we challenge Rami over here, because it's fun, because it's live, post in the chat different things that you do in your Java world that you want Rami to do in the Visual Studio world, and let's have fun with that. I said brace yourself. I didn't say whether they should or you should. I just said brace yourself. Don't look at me like that. This is so
exciting. I've never had this much fun in a recording before. Like, this is just awesome. Like, Jonathan is the best.
Oh, stop it. Stop it. I start blushing. Anyway, go back to the agenda, would you?
Okay. All right. What I'll also cover, which is fairly important for the Java developers, is the differences in garbage collection in C#. So let's start with source file conventions. That's really important. You'll notice that I have Java on one side and C# on the other. In our first example, what I'd like to point out is that C# doesn't have the same concept of packages. It actually has namespaces. And one of the neat things is that you don't need to have one class in a source file in C#. So in Java, you got to have one class, one file, and it's got to be inside a package. You're going to have all these folders. Well, in C#, that mapping is not as strict. So you can have several namespaces in the same file, several classes as well, and you don't need to map your namespaces to the actual file and folder system on your machine. So in this case, we've got a class called customer, and it's going to belong to the Acme package on our Java side. To do the same thing on C#, what you do is you just wrap it around a namespace like Acme. To actually import something like I/O, so to be able to do input and output, in Java the keyword is import. In C#, it's using. So it's very, very similar. If you take a look at the code, you know, like there's differences, the different keywords. I believe that the C# version is a lot more flexible, especially because sometimes I do want to put two classes in the same file and not be forced to split them. Those are the major differences in terms of source file conventions. Okay, the other thing before I forget is that in C# you can actually alias fully qualified names, so you don't have to rewrite the whole namespace sequence plus class each time you use it. You can actually just alias it using the using keyword with an equal sign, as you see on the screen in front of you. One of the neat things that in C# that we've taken from C and C++ for the Java developers who have used those older, lower-level languages, they have pre-processing directives. We've taken that and placed that in C# as well. So what that means is that you can do a number sign with an if-def for a specific section of your code, and that will be executed before the compiler actually compiles your code. So these are pre-processor directives. You can do this in C# and C++. You can't, unfortunately, do it in Java. Jumping on to data types. C# provides all the data types that are available in Java, and we've got support for unsigned numerals, as well as a new 128-bit high-precision floating point type. This is actually really cool. Yeah, it's just
it
really
doesn't
cool.
sound cool. It is cool.
So think about all the math work that you guys do, and as soon as you have like big physics numbers, you know, it's tough. It's tough to be able to do that without losing precision. With C# with that 128 high precision floating type, you can, and you can keep a lot more numbers after the dot. So both Java and C# also provide you with the ability to declare a variable to be specific at compile time, and that can't be changed at runtime. So in Java, this is called using the final keyword. In C#, we follow the C and C++ trend of using the const keyword. Now, strings are a big and important piece of any language. Luckily, in Java and C#, they're more or less the same. They're immutable in both Java and C#. So what that means is when you edit a string, you're not actually editing the string, you're just creating a new one. And comparison between strings is a little bit different. So in Java, you normally use the equals to method. In C#, you can use the double equal sign, and it won't actually do a comparison by reference. It will compare the value itself. So it's a little bit of it's much more like it's exactly the same as when you compare two numbers. So you don't have to adjust your coding style or your coding in general to do comparisons between strings. So we've also got the string builder, which is equivalent to the string buffer class in Java, even though in Java you've also got a string builder class now as well. In terms of converting and casting between different data types, both Java and C# follow similar rules. And here's something that's really neat in C#. You know that sometimes you want to use the back sign, and you got to escape it, so you got to do double slashes. In C#, you can actually use string literals. So just by adding an @ symbol in front of your quotation marks for your string, it won't do any escaping at all, and it'll actually let you put the slash once to mean one slash. So there's an example on the screen, and you can take a look at how when it comes to writing paths to a file somewhere on your system, it's so much easier than having to do the double slash. And you don't make as much mistakes that way as I've done several times in the past. Now, in terms of operators, C# offers all the applicable operators supported by Java, with the exception of the triple right shift, which is unnecessary in C#. This was used mostly in Java to add support for shifting unsigned numerals. Well, because we've got that native support in C#, you don't need to have that extra operator. The other thing that's really cool is that C# also has the keywords checked and unchecked. So this helps you when it comes time to do things where you care about buffer overflows. So it also helps reduce security risks if you're coding, and then you've got the checked keyword as well. In terms of branching statements, if, else, and else if, exactly the same. I mean, the basic parts of the language are going to be exactly the same. There is a difference with the switch statement. So in C#, it actually doesn't fall through. So you must have a break or a go-to. Yes, the go-to keyword. I know that some of you are probably thinking, why would you ever bring back the go-to keyword?
But totally geeking out.
I am totally geeking out. Well, we did in C#, and you can only use it to go to another case. So it's not that bad. It's not that bad. But like it's a way to make sure that you don't have a mistake when you forget to put a break at the end of a case, and then it falls through to the next case in the switch statement. In terms of looping statements, the syntax and operations for for loops is exactly the same. C# has an additional type of loop called the for each loop, which is also present in Java, but it's a little bit different in C#. We use the for each symbol keyword. And if you take a look at the sample code, you got for each string s in array, and then for each time you iterate through the loop, s is your string in that array on top. The other cool thing is that we've also got while and do while, and it's exactly the same. No changes required. If you've got code that is just very basic algorithmic code, it's very easy to just copy it, paste it in C#, and you're good to go. Now, class fundamentals are very important. So the C# access modifiers are similar to those in Java, but not entirely the same. The basic ones like public, protected, and private are the same, but we've got some additional ones in C#. They're a little bit different. So we've got the internal access modifier, and what that one will do is it'll actually make a class only internal to other classes in the same assembly. An assembly is similar to a library in Java, if you're not used to that word. So assemblies are, you can have several of them, and one of the things is that you can do reflection on assemblies and find out what classes are in the assembly itself. By using the internal keyword, you can make sure that things are only available to other classes in that assembly and not exposed to the outside world. The same thing with protected internal. It's another keyword. This is visible only to the current assembly or types that derive from the containing class. So it's another way to modify the access to members of a class without having to make them either protected to all the derived class that may be from another assembly outside. It's a way to just make sure that only internal classes in that assembly can inherit and override these methods. So another cool thing is that in C# you can actually put in a modifier called sealed on a class, and it's going to do the opposite of basically abstract, an abstract class. It essentially forces a class to be uninheritable, so you can't inherit it. You can't change it. It's sealed. The other thing we've got is a read-only modifier. And this is really cool. So it lets you keep a variable set to the first value that it gets on runtime. So you can apply it to a static field as well, but you got to be careful in that you got to set the value of that read-only variable on initialization or on construction of the class. So it's a cool keyword. You got to be careful how you use it and in which cases you use it, but it does help you ensure that some things are only set once, which is awesome. Now here's something that's really cool. You're probably used to writing getters and setters in Java. Well, in C# we've got a language feature called properties. So a property is essentially a named member of a class or interface or structure, and it offers a neat way to access private fields through these get and set accessor methods. So if you take a look at our example, we've got a public class called animal, and we have a private variable. Normally you'd have a private variable called species. Normally you'd have to write a getter and setter, so get species, set species, to change that private variable. But in C# you can actually just easily write a property with a get and set function, very condensed, and it will save you from having to write two different function declarations and two different function bodies. In fact, you can even make this shorter by removing all of the colons after the get and the set and replacing them with semicolons. So remove all the parentheses and replace them with a semicolon. So it looks like get semicolon set semicolon. When you do that, essentially what you're doing is you're telling C# to automatically create a property of that name with the get and set method. So you don't even need to have a private variable that you're actually setting and getting. So it's a neat way to save even more time when you're coding, and that's something that you can only do in C#. Now arrays are very important. A one-dimensional array, as you know, stores a fixed number of items in a linear fashion, and you have one index to be able to identify each one of the elements in the array. In C#, the syntax is a little bit different. We move the square brackets to be right after the data type, so int square brackets. And when you instantiate it, you do new int and you give it a size. Now, of course, you don't have to give it a size. You can just make it equal to a fixed array. And that's what I do in the third line on the screen. Now, both C# and Java support creating jagged arrays. But with C#, what's cool is that you can you can create multi-dimensional arrays. So basically matrices. While both C# and Java support jagged arrays, C# also supports these multidimensional arrays, so you don't have to manually create them. You can just go with a comma, specify how many dimensions in your array. So in my case, what I do is I want to create an array of 2D elements. So I have a square bracket, comma, square bracket, and that's all I need to do.
I'm loving the code writing on the screen. So of course they see us slides, but that's fine. It's all good. It's actually quite entertaining, except I'm seeing it sideways. But anyway.
Yeah, I tend to be very handsy when I present things. It's just the way that I am, I guess. It must be because I'm from Quebec and that's how we do things. We're just very loud and very in your face with our hands. It's just the way I roll, I guess. I'm sorry if it gets in your face sometimes.
Oh, no, not at all. Every time you do that, I just blank you out on the screen like I'm doing right now. and then our audio guy kind of goes and right away puts his hand on the sound bar because Remy's getting too loud. But just remember, I can control what they see.
I should be very wary. So jumping back to inheritance and what happens when you got derived classes. So in C#, both inheritance and interface implementations are defined by the colon operator. So this is different from Java where you have the implements keyword and the extends keyword. In C#, it's almost exactly, well, it is exactly like C++. We have the colon operator instead. So the base class is always the one on the leftmost in your class list. And here we have an example where I'm inheriting a class called coords, and the derived class, the one that's inheriting from coords, is called color coords. So how do you actually access the class that you're inheriting from? Well, you can use the base keyword. And then you also use this keyword when you're building constructors that are specifying a constructor in the parent class. So you can use the base keyword to actually call the parent constructor or just methods in general in the class that you inherit from. So in Java, this is the super keyword. It's exactly the same thing in C#, it's just called base. Now, a derived class may override the method of a base class by providing a new implementation. So this is very similar to Java. It's almost exactly the same. And a method that is to be overridden in a derived class can be declared to be virtual, which will force any class that inherits from that class to actually implement it. And then you can see that this class is being overridden by the override modifier keyword that you need to place next to the function. So an interface is very similar to an interface in Java. It's a skeleton class. It contains method signatures, but no method implementation. You can also make an abstract, they're like abstract classes, but what's really cool in C# is you can also add properties. So you can specify whether a property has a get and setter. So if you only want a property to just have a getter, you can specify that in the interface. Anytime that this is implemented by a class, you can't have a setter for that property. That's something that's really cool. So it's declared identically to Java, and you can have a property that's read-only, write-only, or read and write. Now, here's an example of an interface, very straightforward. You've got your method signature, and in this case, we have a read-only property. So you see you've only got the get with the colon. Now, events are extremely important. An event, if you're unfamiliar with them, I believe most Java developers who have been coding Android apps are going to be very familiar with events. They work a little bit differently in C# and in .NET, but they're very similar enough that you should be able to pick it up right away. So an event is a way for a class to notify the users of an object when something interesting happens. So in Java, what you typically do is when you want to receive an event from another class, you want to create a class that implements one of the listener interfaces. So let's say you're looking for a mouse movement. Well, then you'd implement a class you create a class that implements the mouse listener interface. And then you register that listener with the event publishing object, so the object that is publishing this event. And at any time that this object has an event that's generated, it will call that handler. So in C#, events are members of the publisher class. So in the class that will throw this event will actually have the event declaration within it. And to subscribe to an event, you just basically have to add an event handler method to the event. And you do that by using the plus equal sign. So it's literally like I'm adding a method to this handler to this event. Very straightforward. In this case, the example is we have a window clicked event, do plus equal my event handler, and you're good to go. So Java does provide alternative ways to create event handlers, such as anonymous classes. In C#, you can use anonymous methods to create inline event handlers. So if you're used to having lambdas in other languages, such as Python, you've got the lambda feature. In C# you can do the same thing by using the delegate keyword, and what you'll do is you'll do plus equal delegate with the function parameters, and then followed by a parentheses and actually do something with the event and the parameters that you get in the function, and then you end the semicolon, the parentheses. Very straightforward, very cool. I don't suggest you do this too often, because what's going to happen is if you've got a reference to this class somewhere else and you've deregistered all your event handlers except for the anonymous ones, you'll have some memory leaks. So just be very careful how you do it, and make sure that when you do use it, it's not when you're having multiple event handlers generated for each, for the same event. So exceptions. Whenever something goes critically wrong, obviously there's an exception that gets generated. So in the .NET framework, there's a base class called the exception object. The exception object is the base class for all the exception classes, including, and essentially there's two categories, so there's two branches from that one exception class. You've got the system exception and the application exception. Here's some sample code to see and to show you what it looks like. It's very similar to Java, but there's a few differences, and I'll show you what they are. We first have our try section. That's where you can write the code to do things like open or read a file. You can catch specific exceptions, such as the file not found exception. Perhaps you want to have a specific handling for that error. But let's say for all the other errors, you want to handle it in a specific way. You can you can catch the system I/O exception, which all of the other exceptions above it inherit from, and it will handle all of the ones that are not the file not found exception. Now, let's say that you didn't have an I/O exception, but you had something else, like you ran out of memory or something. You can actually catch all other exceptions by having a catch without any parameter. That's really cool, so you don't need to put in exception E just to catch all the base exceptions. You can just leave it empty, and you'll be able to do that. Now, let's say that you've also want to execute this code without having to all the time, so without necessarily dealing with it in an exception situation. You can actually use the finally keyword, and it will always execute this code, even if there is an exception or if everything works successfully. So now we get to the really interesting bits, such as garbage collection. So if you are coming from a C and C++ background and you were developing native apps using C and C++ and the NDK on Android, well, just to let you know, in C, well, you already know this, but to let you know, in both Java and C# have a garbage collector. So in C and C++, you're used to allocating memory for resources manually. In C# and Java, there is a garbage collector, and the garbage collector will handle deallocating resources when you need it. So in Java, the JVM takes care of that, and it will release all unused memory, and it will keep track of the references as well. In C#, the garbage collection is handled by the CLR. So it's the CLR is the runtime that provides the .NET classes to your C# application. It's very similar to the JVM. So if you're coming from the native Java Android background, you'll notice it's almost the exact same thing. So that ends that section on C# and Java. And I think JR has something going.
I do I?
No, I was just going to say, I'm like, that was rich. It was good. It was a good foundation to actually what we're going to go through. And as much as, like some of you might be thinking, oh, okay, well, duh, or that's a given or whatever. It's always interesting to see the subtleties between the different languages and what isn't subtle, or more importantly, what you think is going to be subtle differently and isn't. Yeah. So in case you were wondering, that was absolutely necessary to brace you for the awesomeness that that we're going to do.